Start.
Welcome to third day of FDP on Advanced Technologies for Energy Efficiency and Sustainability. Good evening to respected eminents, resource persons and participants. Now I would like to introduce our resource person, Dr. Manivannan. It is my pleasure to introduce our esteemed resource person, Dr. P.B. Manivannan, who serves as the Associate Professor in the Department of Mechanical Engineering in IIT-Madras. Dr. Manivannan received his master's degree in Applied Electronics from Anna University, Chennai, and PhD in Control Systems for Engines from IIT Madras. He worked as an engineer in Western Powertrain Electronics India Private Limited and Caterpillar in USA. He has visited as an eminent person. His teaching and research interest includes mechatronics, robotics, sensor network, automotive electrical systems, and industrial automation. He has the visiting research faculty in the University of South Australia, Adelaide, Australia. He was the visiting faculty from University of Nebraska, Lincoln, USA. He is awarded with DAAD Fellowship and Teaching Fellowship from the University of Kaiserslautern, Germany in the year of 2014. Thank you, sir. I will hand over the session to the resource person.
Thank you, sir, for the kind introduction and giving me the opportunity to deliver one guest lecture in the FDP program. Can you give me the this one sharing permission so that I can share my screen?
Sure, sir. Sure, sir.
Okay. Are you able to see my screen?
Yes, sir. Yes, sir.
Okay. Thank you. So, good evening to all of you. Happy New Year. And I welcome all of you for this FDP program, which is arranged by Sri Datta College and the coordinators for the program for arranging this wonderful FDP program and the latest topics, which will enhance the participants' knowledge in the modern world or modern technology in various fields. They are arranged for more than 8 to 10 lectures from eminent persons across the world. So, topic given to me was sustainable battery technologies, innovation and challenges. Of course, I just added one more small phrase for cleaner and greener world. Why do you need sustainable battery? Is for greener and cleaner world or environment, which is very important for sustaining the global community. So that's why I have selected this topic. They are also agree. Thanks for that. Now, people talk about, whenever I want to talk sustainable, you go around the world or attend any conferences or journals or papers or these workshops, you will definitely come across what you call some 2 or 3 words or phrases. One you call global warming, other one is greenhouse gases, then third one is sustainable world, sustainable environment, sustainable energy, or sustainable buildings. Like that, you will come across these words frequently. Because my talk is related to that, that's why I just wanted to talk about that. First thing is global warming, greenhouse gases. Global warming happens because of the greenhouse gases. Please note that I highlighted in green color, but please note that the greenhouse color are 2 dangerous gases. They are not really good. Generally, we say green means good, right? Plants, all those things. That is the human nature, or we generally paint in green color, or we say green. Green means good. But the greenhouse gases are really too bad for the environment as well as the earth. Also, the living organism, including animals, trees, humans, for everybody. So if the greenhouse gases are emitted too much and it mixes with atmospheric air, it increases the temperature of the atmosphere. That if the temperature increases, we call it a global warming, because we know that Earth from the surface up to few kilometer height, you have the air. We call atmosphere. In the air only, we have nitrogen, oxygen, carbon dioxide, water vapor, dust, all those things, including clouds. All those things are in which living organisms are flying, or the artificial machines like aircraft, helicopters, all those things, what we have, they are all flying, for which we need atmospheric air. But we know that the majority of the concentration of the gases are nitrogen, which is called as inert gas, 77% by volume. Around 22% is oxygen, which is very important for all living organisms, including plants, insects, animals, fish, birds, for anything. Without that, metabolism will not happen. Living organisms need oxygen. With glucose, they do metabolism, produce energy, all those things, they will go. So, but we know that the carbon dioxide is produced when fossil fuels are coal or wood. That means carbon-based fuels are burned in the atmosphere. Then the outcome is heat plus heat energy plus carbon dioxide. But the carbon dioxide also, we know that it is inert gas. That's what known to us, like any other inert argon, all those things. That means it will not react with anything. It will not do any harm. It will not corrode materials like oxygen or any other gases, fluorine gases, something like that, or chloride. But this is, but recently, around 30, 40 years ago, they found that it is one of the global, the greenhouse gases, which heats the Earth atmosphere. Okay. If the global warming happens due to the greenhouse gases, CO2, other gases also we'll see in the subsequent slide. Because of what is the effect? It produces unpredictable weather, like severe cyclones. Correct? Cyclone will come very high speed, 200 kilometer, 180 kilometer, and heavy rain. Correct? And then you have what you call frequent cloud burst. Instead of rain, what will be? It happened some 3-4 months before in Tamil Nadu, with a place called Tuticorin. 50 centimeter rain within 24 hours. 50, that means half meter rain within 24 hours. Entire districts, cities were flooded. Many people got affected. Crores of rupee worth of properties and agriculture producers, and also humans, also few humans also lost their life because of the cloud burst. That means generally it doesn't happen, but nowadays it is happening frequently. Cloud burst, severe cyclone, high speed, this one, tornadoes in US, in Asian countries, we get what you call the cyclones, and flooding because of heavy rain, all these things. Because of we lose humans, excessive damage of property, environmental, landslide, forest fires, etc. Also, sometimes not only rain, sometimes severe drought also comes. Now, if you see news, CNN news or in internet, you'll see that in California state in US for last 10-15 days, the forest fires are coming because there is no rainfall as this one, very dry condition, heavy wind, correct, around 160 kilometer speed wind is this one. Because of that, the fire which naturally comes due to forest fire is spread over 10,000, 20,000 hectares and burned property worth of billions of dollars. They're talking billions of dollars, correct? And many, more than 100 people or 80 people lost their life, and 10,000 people without home for last 10 days or 15. Correct? Losses and billions of dollars. This is also due to global warming. That means we don't have regular weather pattern. We know that 3 months will be summer, another 3 months will be winter, another 3 months will be rainy season. Then you have spring season, some 4 seasons. This is what there for last at least thousands of years on the earth. But last 20, 30 years, it has been changed. Correct? The weather pattern changed, all due to greenhouse gases, which affects the global warming. Okay. This because of global warming, the unpredictable weather happened. Apart from that, polar ice, correct? Antarctica, Arctic ice also melting, and also Himalayan ice glaciers, where the Ganga, Yamuna, Brahmaputra, these rivers are originating. They call ice glaciers higher up. This is there for thousands of years. They started melting too much. In fact, the river Ganges starting point we called a Gaumukh which has retreated 3 kilometers in last 200 years. The starting point of the river Ganges, it has retreated. The starting point from a glacier, Gangotri, where a small cave, they call Gaumukh. There only actually original water starts, a small stream, melting water. Now it has retreated 3 kilometers last 200 years. They say within another 50 years, if global warming is not stopped, the more Himalayan ice will melt. Gangotri glacier itself may not be there. And you will not get water in Ganga, Yamuna, Brahmaputra within maybe maximum 100 years if global warming is not stopped. That is due to three gases. That's what we are going to do. What are three greenhouse gases? One is called carbon dioxide. This is primarily produced due to burning of fossil fuel, hydrocarbons, or wood or coal. Then next one is called methane gas. This is produced when biomaterial decomposes. Correct? When that is including digestion. Like cow eats grass, or animals are eating herbivorous animals. Elephants, cows, horses, donkeys, goats, all these deers, all these things are herbivorous, which is a plant. They eat. During the digestion in the stomach, it produces methane gas. Apart from that, when trees are go inside the earth surface, correct? They decomposes when mixes with the sun. That time also it produces methane gas. We call it natural gas something. Methane gas also. Combustible gas that can be used as a fuel. You can please note that methane gas can be used as a fuel, like a LPG gas. If you burn that, again it produces carbon dioxide. And the third one is CFC gases, refrigeration, used in air conditioning, all those things. And also NOx, nitric oxides, which is produced by lightning, high heat condition inside engine when combustion temperature high, all those things. These four items are made. Out of that, we can see that because of what is the greenhouse effect or greenhouse gases, why it is called so. As I told you, you can see the left side I am showing a house. If you go to Ooty or go to Bangalore, Lalbagh or any this one, you will see a building. Top roof is covered with glass, and inside that they put the exotic plants, flowering plants from England, Canada, Japan, US, or Germany, which is from cold countries. You will roses, tulips, or special type of flowers. They will be really very beautiful, bright colors compared to flowers of the tropical region. But those plants we cannot live in hot temperature. Like for example, take Chennai. Correct? Here the temperature, lowest temperature winter now. Now we are in the winter. In winter itself, it is only 20 to 24 degree. This is really very high temperature for these plants. Similarly, if you go to, if it come to summer, it goes to 40, 45, Delhi, even 48. So this plant cannot live, but they look beautiful. So what they do, they build a building in which the roof is made with glasses. So the plant need sunlight for photosynthesis, otherwise it will not grow. So the sunlight will come in, but inside there they control the temperature and humidity, all those things maintain similar to Japan or US or Canada or Germany or UK. Where the plants are brought around 18 degree, 17 degree, so that they can grow, and we can go inside and see this. So the main with this one is why this one, the light can come in, but the heat from outside cannot go in. They use a special glasses. Similarly, the cooled air inside cannot, the temperature cannot go. So it is controlled environment, temperature controlled. That's why it is called as a greenhouse. The temperature is maintained, particular humidity, all those things. So the plant grows. Similar to that, Earth atmosphere also becomes like a this greenhouse. What happens? As I told you, you have Earth surface below, and above that, the black color. You see the right side I'm showing. You have a sun. This is the space. Sun is I shown as a pictorial representation, but you know it is in millions of kilometers away. The sunlight takes 8 minutes to reach Earth. Right? Light from the sun takes 8 minutes approximately to the Earth's surface, far away, but far west. Now, sun emits light. It also contains infrared light. Correct? We know that VIBGR color, white light contains 7 primary colors. Correct? Visible colors. Apart from that, it has infrared and ultraviolet. So the infrared only contains 80 to 90% heat coming from the sun. It is what carrying infrared light carrying. That light coming from the infrared comes to this one. Go from the sun, it hits the Earth's surface, but the light is flowing through the atmosphere. So that IR heats the earth surface also heats the atmosphere. For example, morning time when the temperature, for example, take Chennai, now is winter, morning it may be 20 degree, correct? When sun start rising from the dawn, correct? Then it heats the earth atmosphere in India, correct? This part of India. You, of course, other side, America, all those things, it will be night, where the earth atmosphere will be getting cooled. Now, the temperature start increasing. In midday, it becomes maybe 28 degree, 30 degree. By evening, it is around 27, 20. But when sun disappears after the sunset, the atmosphere in this part of the country, Asia, Europe, all those things, Japan, all those things, start radiating. The heat received by the atmosphere, which absorbed by the gases in the atmospheric air, which contain nitrogen, oxygen, carbon dioxide, other gases, dust, all those things, they re-radiate the heat back. That's what you can see the arrow going down. When heat is coming down, you can see bigger arrow. When sun is shining, night time, the heat from the atmosphere, that is the air, goes back to space, because you know the space temperature very, very low. It can be lesser than 0 degree, minus 200 degree also, correct? Above 400 kilometer, there's no air. The entire vacuum, we call it vacuum, that the temperature can be very low. So that means the heat in the atmosphere will return back. But as I main thing I want to say is other gases, nitrogen, oxygen, all those things, whatever absorb, most of the within 12-hour period night time, they really gives back to atmosphere. They come to next day morning, it will be 20 degree. For example, I told you, correct? But the carbon dioxide molecules alone don't, or methane, or CFC, these four gases doesn't give back the heat fully to the atmosphere. They retain some amount of heat. Because of that, the atmosphere temperature next day morning, instead of become 20 degree, it may be 25, not 1 degree. Please know that not 1 degree, I told you for example, correct? Very small, this one. But this is per day. Within a year, 365 days, correct? Within 10 years into 3,650, correct, days. So every day the temperature go on increasing. The from 20 become 21, something like that. I am talking this part of this one. Now, the earth surface is very big. Volume is big, correct? Atmosphere, it extend up to the atmosphere up to 10 to 15 kilometer height with so much circumference, thickness. If you see the volume, so much air is there. The average temperature atmosphere, I told in Chennai temperature. But during the time, if you go to Antarctica, it can be minus 20 degree. If you go to Arctic, it may be minus 5 degree. And the air is moving, correct? The atmosphere air is continuously circulating. Because of the wind is there, we are getting weather pattern, this one also, rain, clouds, all those things. Wind movement is very, very important. Otherwise, you will not get rain, all those things. So the air at different temperature. Arabia, it may be 50 degree. Chennai, 20 degree. Delhi, 5 degree. Antarctica, minus. All the air are making. They say average atmosphere temperature is around 1 degree, correct? Or 0.5 degree. Some to 200 years before. But now they say, because we are burning a lot of fossil fuels like petrol, diesel, and thermal power plant, coal in thermal plant, and LPG gases in cooking, house heating, all those things. We are producing electricity by burning fuel or directly burning fuel in the engines or jet engines, all these things. We are emitting carbon dioxide. Okay. This carbon dioxide is byproduct of a combustion of the what you call hydrocarbon fuels, correct? Like petrol, diesel, LPG, methane. They contain carbon atom plus hydrogen. This is a chain of this one, carbon plus hydrogen. We call hydrocarbon. This hydrocarbon, if you burn, they mix with oxygen in the air. Byproduct will be CO2 plus H2O, water. So automatically, but many times doesn't happen. That is for perfect combustion. We will talk about later. Now, the output of the engines are, whenever you burn the hydrocarbons or coal or wood, output will be carbon dioxide. The carbon dioxide, if I produce more and more, the volume of the carbon dioxide increases in the earth atmosphere. So it retains more heat than the average atmospheric temperature of the earth increases from 1 degree. Now they say presently 1.5 degree, correct? Plus 1.5 degree centigrade. From it become around 0.5 per 1 degree 100 years before, now it become 1.5 degree. You may think it is very, very small. But because of that only, this thing happens. Ice, you know what is melting point ice? All of us know that it is 0 degree. Is the freezing point, water, and become ice. If temperature increase above 0 degree, ice start melting. That is why Antarctica, Arctic, all these things, ices are melting. Average global temperature now will become 1.5 degree. Because of that, the ice is melting. Because of the water, sea water level is increasing. Okay. And the polar ice means they say that the water level can go up to 10-meter height. That means many coastal cities like New York, correct, Bombay, Chennai, Vizag, Calcutta, Tokyo, big cities, correct, which is around the world, they will go inside the water because 10-meter water, because IIT-Madras is maybe 5 to 8 meter height from the sea level, because we have the Bay of Bengal, just 1 kilometer, 1.5 kilometer away. So if Bay of Bengal water level increase 10 meter, 20 meter, correct, because of melting of solar, there is Antarctica, glaciers, Himalayan, Arctic glaciers, all those things, the overall water level will increase 10 to 20 meters. That means 60 feet also it can go. They say average, correct? So that means many cities will go. That is also danger. So all these things should be avoided. Means what we have to do? We have to reduce the production of CO2, which is called as a greenhouse gas. Correct? It is a dangerous gas. So it should not be produced. That means you should not burn fossil fuel at all. Correct? Petrol, diesel, kerosene, LPG gas, methane, wood, coal, nothing should be burned anywhere in the world. Correct? If you burn, that means you are injecting or adding more CO2. If you add the global average temperature, presently 1.5 degree, they say if you don't control the fuel burning, reduce the fuel burning to zero within another 10 to 15 years, the temperature can go up to 2 or 2.2, then most of the ice will melt. Then the problem what I told will come. So that means we have to reduce the burning of fossil fuels and wood and coal. Okay, where we are using, we know. We are using, as I told you, we are using fossil fuels for heating, cooking inside the house. Correct? India, no problem, tropical country. We don't need this one heating. But if we go to Europe, correct, USA, Canada, Japan, China, Russia, all European countries, or go to Australia, in winter, the temperature goes even minus degree for 2 to 3 months. The entire house should be heated. Otherwise, nobody can live inside there. Correct? We have to make human body requires 18 to 20 degree to maintain body properly. So at least 20 degree, 22 degree, not lesser. Then you will get shivering, you will get fever, all these things. So you have to maintain. So that means they burn a lot of fuel. Billions of barrels of oil will be burnt throughout the northern hemisphere countries, majority, correct? Starting with Japan, China, Russia, European countries, Canada, USA, and also Australia, some part in the southern winter time. They burn huge amount of this one oil for heating the house, or gases, LPG gas, something like that. Or they burn coal, heat it, water, and circulate inside the house. So that is to be this one. Similarly, factories. Without energy, factory will not run. Because any machine, if you want to create a motion, you need energy. Generally, they use electrical energy or directly driving. Correct? The engine may drive a machine. Correct? Or electrical motor may drive a machine in a factory. Robo. All the machines need energy. Those energy generally is 99% nowadays, or 95% is electrical energy. That electrical energy is produced in thermal power stations. Correct? 80% of global energy is produced by thermal energy power stations, which burn coal or heavy oils, crude oil, heavy oil received from crude oil, billions of tons. Correct? Every year they are burning. That means billions of tons of carbon dioxide is added to atmosphere every day because of power production to run the factory. Then, of course, come to transportation. Correct? Car mobility. Correct? Motorcycle, cars, buses, truck, then trains. Correct? Ships. Then, of course, the planes, jet engine, they are also burning jet fuel. Again, it's a hydrocarbon. All these things are burning billions and millions of tons of fuel for transportation. But without transportation, people, society cannot live. Correct? You have to transfer food grains, passenger have to go one place, another, you have to go to office, come back, all these things. So all three are consuming energy. These three forms the important part of the society. Without that, people cannot live. You need a place to live and sleep, eat, all those things safely. You need a house. You need factories to produce the items. What do you need? Whatever is the product, it may be paper, pencil, TV, correct, or computer, or entertainment, or machines. correct? Food processing, everything you need energy, correct? It is made in factory. Then automation. All these things are burning fossil fuels. So why? Okay. Now I said for the lighter sense, I put this green building, green factory, green vehicle. You will hear this word frequently. Go to convey. I guess I told the first slide sometime 20 minutes before. People talk about this. We have to build green building, green factory, green vehicle. Correct. So for lighter sense, correct. I take a building. My house is there, for example. I paint my entire building green color paint. Okay. Will it become a green building? Absolutely no. I take a factory, inside factory, walls, inside machine, everything paint is green color. Will it become a green building? No. I take a car. I have a sports car, for example. Or I paint my car in green color. Correct? Will it become a green vehicle or green car? No. What it means, green building, green factory, green vehicle means they are using energy which was produced by not burning fossil fuels and coal, correct? As I told you, for example, my house needs heating, electrical heating. I have a cooker, correct? LPG gas. Then I have a grinder, I have a mixie, I have a TV, I have lights. All these things require electricity. That is produced in a thermal power station. I told you, you have hydroelectric power stations, correct? And you have nuclear power stations. And the majority of the power is produced thermal power station, correct? Now, we are going for next level, what you call renewable energy or green energy. We will talk about next slide. That means if I run my house, all the utensils, all those things use energy in a factory or a car, for which the energy, for example, electric energy produced in this is generated by not burning. Please note that not burning fossil fuels or wood or coal. That means I am not producing any CO2 gas. If I burn, definitely the output will be CO2 gas, any of these things. If I don't burn, instead of that, use any other technology, any other material to generate my electricity, use the energy to heat my house, cooking, run my factory machines, run my car. Then only that is called a green building, green factory, green vehicle. Okay. But as I told you, without energy, you cannot live. Correct? No human can live because we already used to for hundreds of 100 years. So, energy generally, many times, the energy used is a heat in the form of heat. Correct? As I told you, inside IC engine, correct? Diesel engine, petrol engine, or jet engine, fuel is mixed with the petrol or diesel, LPG gas, or jet fuel, compressed and given a spark, it burns. Then it produces a heat. Because of that, there's the gas expands, it generates a torque, correct? Rotating force called torque on the wheels of the car, truck, bus, or inside generator, and it may driving a generator put electricity which is going to zero. So living organism need heat, which is called as a metabolism, without which the cell will die, correct? We know that if you touch your body, you know what is the temperature, correct? It should be, if your body become cold, what they call, already you are dead, correct? So your temperature, body temperature becomes zero, close to that means you are no more living. So the cells are producing heat. Individual cells, we have trillions of cells in our body, trillions I'm talking, correct? In the body consisting of maybe I say for example I'm 60 kilo, I may have some trillions of these individual cells which forms individual organs, skin, heart, stomach, liver, eyes, correct, brain and bones, skin, all these things are made of small cells living. These cells need the glucose and oxygen. Oxygen is received by inhaling through lungs. It separates and it is mixed with blood and goes to individual cell, and we eat food. From that we get glucose, which is called a carbohydrate, that also mixed with blood. Blood carries to individual cells. Individual trillions of cells receives the food in the form of glucose in the blood and also oxygen, which we are breathing through our lungs. So then cell combines with glucose. Please know, glucose also carbon plus hydrogen only. Glucose molecule consists carbon plus hydrogen, correct? That will be split into carbon and hydrogen in the inside the cell, and it combines with oxygen, and so it becomes CO2. Individual cell produces CO2 and also water, H2O. correct? So that will be again into bloodstream, and it is comes as a sweating or through your urine as a water goes out, sent out, and the heat is maintaining body, cells are growing. So they're called metabolism. Okay. So similarly, this is living organism, but our interest is today lecture is not about talking about the biology, all those things. Our interest is sustainable battery technologies. That's what we are going to talk, but this is directly related to sustainable battery technology. That's why as introduction, I'm just talking about this. So primarily heat is needed for house, for transportation, for running factory, correct? Forget this one. As a humans, we need all this thing. They call energy. Heat energy is vital for running factory, automobiles, everything, correct? Or generating electricity, correct? But if you are able to generate electricity without using heat, that is better. That is called as sustainable energy, renewable energy generation, without using the burning of the coal, all these things. We'll see that how to do. Sorry. The energy sources. What are the energy sources available? Combustion of wood, coal, hydrocarbon fuels called liquid fuels can be gasoline. We call it petrol in US called gasoline, diesel, heavy oil used in factories, power station, thermal power station, jet fuel for jet engines, and gas is full like LPG, natural gas, etc. Generally, we burn this, produce heat, and that heat is converted to mechanical energy to do some work or for heating house, cooking food, all those things. Directly may use the heat or convert into mechanical energy to do work in the factory or move the vehicles, all those things. So this is the primary source, as I told you. This is the primary source of the energy for humans in throughout the world. At least 80% of energy produces by burning this first process. Second one is nuclear energy. We know that by splitting the atoms, which is called fission of the material, fission like uranium, plutonium. If you split it using neutrons, while splitting this one, they release energy, correct? That energy is called as nuclear energy, fissionable energy. Other one is called fusion energy. We are yet to accomplish, but fusion energy is already supporting the entire universe for billions of years, at least 13.6 billion years. Universe was created 13.6 billion years before, and sun was created something around 5 billion years before Earth and sun, and sun is producing heat by fusion, not by fission, correct? Fusion is joining two atoms, or in this case sun, it is two hydrogen molecules join to produce helium atom. This process is called fusion. That process only produces the heat and light from the sun, which is sustaining energy, providing sustainable energy to the earth for last 5 billion years. And not only for human, all living things, including plants, animals, birds, humans. Without sun, we will die within few days. Okay, so that is nuclear energy, but that energy we are trying to do. But of course, humans are able to use fusion energy to make a bomb, hydrogen bomb, correct? We call it, which is more powerful than fission nuclear bomb, which is called fission bomb. But right now we are using fissionable material, including Chennai. We have Kalpakkam, Bombay, Trombay, many places, Kodangulam, in India also, nuclear power. They provide around 10 to 15% or 12% energy worldwide. Then next, nowadays we are trying but nuclear energy has other side effects, so we don't want to use because they have radioactivity, and radioactivity is harmful to humans, animals, living organisms. So throughout the world there is a agreed this one to reduce the nuclear power plants, because the plutonium produced in the nuclear fission from the uranium has a half-life time of 10,000 years. Talk about 10,000. Human life is maximum 100 years. You talk about 10,000 years, so many generations. So if you get in contact with plutonium, your body cells will be destroyed, you will die. So it is highly dangerous, radioactive. You should not go near radioactive material. Storing the radioactive plutonium nuclear power plant is such a big problem worldwide for the last 60 to at least 70 years. So that also there's a lot of this one dilemma whether to go with nuclear or this one. But best thing is going for renewable energy. renewable energy means producing the energy needed. Correct? Energy in the form of electrical energy or direct heat energy from solar, that means from sun, or wind. The wind is moving because of wind energy, wind turbines, and wave energy or geothermal energy. Also, what you call thermopiles. Also, there is a called thermocouple. If the junction is heated, it produces electricity. Right? So that's what thermocouple. If I have hundreds of thermocouple, I can produce electrical voltage. That voltage may be in each thermocouple produces a 10 to 20 millivolts per given temperature. If I connect some 200 to 500 thermocouples in series, I may generate up to 10 volts. That is generally this is used in satellites when satellites are going far away from the sun, because sunlight is not possible. In satellite use what you call solar panel to produce electrical energy. But when, for example, we are sending America, India is sending Mangalyaan, correct, to Mars, and America sent Pioneer 10, Pioneer 11. They are beyond the solar system itself. They are around 4 billion or 8 billion kilometers away. They launched in 1972 or 75. In the last 50 years, they are out of the solar system. Neptune, Pluto, everything class, correct? 3 years before. Still they are working, correct? Even after this one. So they use what you call the thermopiles with the heat source as a nuclear power, correct? Low heat generation nuclear power source from the heat is used to generate electricity to run the computer sensors in this one. That also. So all these things are called renewable energy or green energy, correct? Or because they are produced without burning fossil fuel. Now, this is what the future. This is what everybody wanted to do by avoiding burning fuels, correct? Which is combusting the fuels, hydrocarbons, and also nuclear energy is dangerous. And instead of that, try to go for this one. If I generate or use the energy from this one, it is called a renewable. That is what's called sustainable energy. Correct? So another thing is chemical energy. Batteries are working based on all the batteries, correct? Whether dry cell, what you're using, torchlight, radio, TV, or cell phones, or in car, wherever truck, any type of battery, how they produce energy. They produce electrical energy by converting the chemicals, because battery contains a chemical what you call electrolyte, and also has two metal or this one non-metal, this one two electrode, positive and negative electrode, and there's a chemical reaction between the electrolyte and electrodes which produces electricity or electrons. That is called as chemical. It is a chemical energy based device, but that is also very limited, because making battery is not possible. We need gigawatts, terawatts of energy, because we know that more than 7 billion people are there here, correct? Many countries. We are spending huge amount of energy, electrical energy, all the energy. So that means we need to generate sufficient energy. Batteries alone not possible. That's why we are using thermal energy produced by through which we produce electricity. Okay. Now I am coming back to what our topic, sustainable. Still, we need to go for sustainable battery. Before that, quickly I go to this sustainable energy technologies. Correct. First, what do you mean by sustainable? Correct. Sustaining. Correct. The word English is normal word. Forget about technology. Sustaining and maintaining or continuing. That is the meaning for sustaining. Okay. Sustainable energy. Sustainable energy technologies. What it means is technology using which I can produce, for example, electricity. Now, today, tomorrow, day after, next month, next year, after 10 years, after 100 years, 1,000 years, hundreds of years, if I am able to produce electricity or energy from particular source, then I tell that source is called sustainable energy source. Okay, just 2 minutes before I told, take sun. Suppose if I am producing electricity using solar panel from the sun, sun is there for last 5 billion years. Right? I'm talking about billion means 5 into 10 power 9 years. Correct? Now we know people already, astronauts, other scientists have found that sun and earth, solar system was produced 5 billion years before. Now they are, sun has consumed 50% of its fuel. What is that? Hydrogen for the fusion, and it is producing energy and is sending heat and light to earth and all the planets. And now it is in mid-age, correct? If I think that sun will live for 100 years, already sun has lived for 50 years, including earth. 5 billion years before, that's what the calculation by research they found. 5 billion years before solar system was formed, sun is around 5 billion years old. It will live for another 5 billion years only. Based on amount of hydrogen available, it can sustain the fusion and create heat and light and supply to earth for another 5 billion years only. After that, sun will not be able to produce heat and it will collapse. It will become a red giant, and the sun size will become so big, earth will be inside the sun. Please, if you live for another 5 billion years, you will see that suddenly one day, in few seconds or few minutes, correct, the sun will explode and it will become a red color, and earth will be inside the sun. That is the end of the sun and earth, our entire solar system. So we have another 5 billion years. So if I'm producing energy using solar cells, using light from the sun, I can call it a sustainable energy. But I cannot call the this one thermal power station, which uses coal or heavy oil or diesel. By burning, it generates steam, which drives the electricity generator, and because of that I'm getting power. We know that already many times you would have seen newspaper, all this thing, because I know 1970. Say I am already around 59 years old, 60 years, correct? 1970, when I was studying in school, they said that the oil extracted, crude oil extracted in Iran, Iraq, Saudi Arabia, worldwide will exhaust within 10 years. Correct? After that, no oil, diesel, petrol will be available. Correct? So the petrol price, diesel price suddenly increased in 1970. A panic was created based on the availability of crude and throughout the world. Then they said you have to find alternate energy sources to run your bus, all those things. Then they were talking using hydrogen fuel, hydrogen as a fuel, correct? Or any other means, solar energy, wind energy. All the research are kick-started in 1970s because crude oil will be exhausted, correct? Then they found new crude oil wells, correct? Oil wells, Arabia, India, many places, correct? Iran, Iraq. Then they said, no, you need another field. Enough crude is there. They invented Russia and Alaska, all these places. They say another 60, 70 years will be there. Now again they're saying, correct? Maybe after 50, water may be the crude oil going to exhaust after 50 years, maybe 100 years. After that, where you will get the energy? Because no IC engine. That means all your cars which are running petrol, diesel, LPG, nothing will be there. How will you cook? How will you heat your house? How will you run your factory? Nothing is possible. That means you need to find a sustainable energy sources from which we can generate energy. Correct? For example, mainly we are using primary electrical energy. So solar energy using solar panel, wind energy. Correct? As long as the earth is there, correct? So human history itself only 6,000 years old. Correct? Mohenjo-daro, Harappa, we say Indus Valley civilization. Correct? 5,000 years. Egyptian civilization, 5,000 to 6,000. Chinese civilization, or Mesopotamia in Iran, Iraq, all those things. These are the 5,000, 6,000 years. We say that humans itself came from monkeys, correct? Homo sapiens, correct? A million years before, few million, 1 year, 2 year, from Ethiopia. Starting origin of the human, they say that they discovered the bones, skull of the early humans. From the carbon dating, they are able to say that is only 1.2 million, 1.6 million. That also from Ethiopia. From there, from monkeys, a particular type of monkeys become Homo sapiens, which was able to walk with 2 legs. All this become modern humans. Correct? They spread from Ethiopia, they went to Europe and Asia. From there, they went to North America, Australia, all those things. Just a million years before. But known people, correct, who can write, read, construct house, construct temples, buildings, dams, all those things, only 5,000 years. Correct? So that is different. But we need a sustainable. Wind is there for millions of years. Earth, once Earth was created, maybe after Earth, I told you, Earth life also along with sun it produced maybe 5 billion years before. Correct. So they say the oxygen, all those things came 1.2 billion years before. Amoeba, all those things came some 100, 500 million, something like that. Correct. We are talking millions of years, less than a billion years. So that time, air was available. Air will be available at least for another 2 to 3 billion years or 5 billion till the earth is consumed by the sun. So if we are able to produce electricity from wind, correct, then wind farms, correct. So that is called as sustainable energy. Please note that solar energy doesn't use burn fuel, correct, hydrocarbon fuel, so it won't produce CO2. Wind energy, wind turbine, correct, does not consume fossil fuels, but still produce electricity. So similarly, geothermal energy you can use, correct, and all these things, if you otherwise you can use other type of energy or nuclear energy, correct. All these things are called sustainable energy, but nuclear also you need to find uranium, all those things, correct. Mining, all those things you have to do. But wind, correct, wave energy, geothermal energy, heat coming from the volcanoes, near volcanoes, correct. The Iceland, Japan, many Russia, many places, the hot water springs are there. Steam will be coming out. Otherwise, you make a drill, correct, like a borewell, pump water inside the earth, maybe 1 kilometer, 2 kilometer. Below that, the temperature is around 200, 300 degrees. Water will become a steam. Get back the steam, use it for driving the turbine, produce electricity. They are called geothermal, correct? Which Iceland produces more than 95% or close to or even 10% geothermal energy without burning fossil fuels. The best country in the world which is a really a sustainable energy source using is Iceland. But it is a small country. But we are also, you can do that. If you do that, then we'll say that we have invented. Already these technologies are available, but use of is very limited due to various reasons compared to burning the fossil fuel. Okay. So again, sustainable energy source, as I told you, these are sustainable also solar energy, wind energy, wave energy, geothermal, correct. Thermopile, you just forget a small thing, and of course batteries. Okay. Now that we till now we talked about what is the problem of burning fossil fuel, correct? Why we need to look for sustainable energy sources or renewable energy sources so that we can stop the global warming, so that earth environment is protected, so that humans, animal, all the plants. Otherwise, the humans, they say humans will destroy the earth itself within 100 years. If we allow it to burn the fuel, the rate at which you have to making cars, motorcycle, burning, see, computers also using, we do, many times we think that driving motorcycle or driving a car or flying the aircraft, burning fuel, correct? Not only that, your computer is consuming current, correct? Billions of computers, billions of TVs, billions of cell phones, correct? And you know that your data is stored in the cloud by Google, all those things. You know the cloud storage consumes, they have separate power stations. Google has power station, correct, which is producing gigawatts of power per year. Otherwise, they cannot store your data. So that means we are burning to produce this energy for running TV, computer, data storing, internet, cell phone, all those things. The companies are burning lot of coal, petrol, diesel, all those things, and producing electricity. So that also should be, those energy, also the electric energy should be for running your computer, all this thing, TV also should be produced by from the renewable energy sources, correct? We should not produce for non-renewable energy sources. What is that? Petrol, diesel, wood, coal. All these things will exhaust after 100 years because it was produced for millions of years. We have consumed within the last 200 years. Coal was produced after hundreds of millions of years when the trees, all those things went due to volcano, earthquake, went inside this one. And the crude oil was produced for last 200 years because of pressure and temperature, and which was produced for hundreds of millions of years. We are just consumed within last 100 years or 200 years. Maybe within another 100 years, completely exhaust. All minerals, coal, diesel, nothing will be there. Rate at which we are using. So we should go for renewable energy sources. Okay. Coming back next, we are talking about battery. But why? Because of that, I'm going to talk about where the batteries are used. Batteries are used, cell phone, everywhere, wherever you need electrical energy. Since I am working on the field of autonomous vehicle, electric vehicle, hybrid vehicle, that's what one of the areas. I work on robotics, I work on control system, I work on mechatronic design. Another most important thing is my PhD itself for engine control system developer ECU, and still I was last 30 years I working on automobiles. Correct. I worked in Ford. I worked in Caterpillar in USA as a sabbatical. Doing my PhD work itself for engine control system. Still, I am working. My students are doing research on autonomous vehicle, driverless car. That means I am going to control engine and electric motor in autonomous vehicle. So, because of that, today I am going to talk about the electric and the hybrid vehicles, what they are, and then we'll talk about battery quickly. Okay. Now, coming back here, why we did, see, for example, if I want to transport something into one place to another place, you need vehicles, correct? Passenger vehicle and goods vehicle, correct? When you talk about a passenger vehicle, it can be two-wheeler, correct? For example, motorbike, which is run by a battery or an engine, petrol engine, or a car run by diesel or battery or a petrol, or a truck or bus, generally by the diesel fuel, correct? Nowadays, the electric bus, electric trucks are also coming. Then you talk about jet engines, jet planes. They use jet fuel, correct? And ships, for generally ship, nobody using for passenger, very limited, except luxury liners. Ships are one of the important for transporting goods, huge amount of 1 million ton, correct, of the crude oil transport from Saudi Arabia to Chennai or Bombay, correct, crude oil or anything, container ships, food, all those things. Sorry. So you need vehicles. So the vehicles can be electric vehicle or it can be IC engine. Generally, now we are talking electric vehicle for last 20 years or hybrid vehicle. But generally, old generation, myself, all those things, we are very old. When I say car, bike, truck means immediately I will do in my mind, I will get these pictures only. This is what I see in the road, correct? Different type of talk about car, correct? Sports car, race cars, correct? SUVs, sedan model, something like this. All these cars are generally driven by petrol engine or diesel engine. I will talk the specific example right now, talk cars, correct? Petrol car or diesel car. These were there for last 100 years, correct? Please note that petrol engine itself was invented 100 years before. Diesel engine maybe 90 years. Maybe petrol engine maybe 120 years by Otto, a German scientist. And diesel engine invented by Rudolf Diesel. Again, he is an Austrian scientist. Austria was under control of German Empire, correct? So both the people are from Europe. They invented Rudolf Diesel and Otto. They invented petrol engine and diesel engine, correct? That's why they have to honor them only. They call it diesel engine. Other one is the Otto engine, correct? That's what we call the petrol engine. Okay, so they are this one. These, as I told you, these cars are burning petrol or diesel. That means they are using non-renewable energy or greenhouse gas producing energy, correct? So that means these cars should be eliminated. Literally speaking, the word I should not use. These cars should be eliminated, completely removed from the roads. And instead of that, I should have this vehicle. What vehicle? Electric vehicle. The electric vehicle takes the energy from the battery, electric energy, drives the motor is driven. The motor produces mechanical energy that is connected to wheel. So the vehicle moves from one location, transporting humans or goods. So if I use electrical vehicle, then we can reduce greenhouse gases. One thing. Please note that this vehicle, electric vehicle, this picture I took it from internet. It was made by Robert Anderson, this person, this person, in 1832, and it is an electric vehicle. That time, petrol engine was not invented. I'm talking about approximately 200 years before. Car was there, but it's an electric car. Okay. Then Thomas Edison, you can see here, this is Thomas Edison sitting along with his friend George, correct? And they made an electric car. He is driving. You can see that they're traveling in US in 1909. That time also diesel engine was not invented, or maybe just an experiment. Petrol engine itself very experimental, not used in the cars. It was an experimental changes. So this is an electric vehicle. Okay. Then this photo again took it from internet. You can see in New York Street, Main Street, New York, US, correct? You can see a lot of cars. This photo shows lot of cars 1900, 125 years before, correct? You see this car, all these cars are electric cars. Please note that these cars are not petrol engine car or diesel engine car, because diesel petrol just invented, they are not used in any vehicle, they are testing. So that means then now we are talking about the electric car. We think we as if we are invented. The first mobility or cars were electric cars only, 1830s to up to 1910 or 1915, correct? Up to that, cars were there, they are electric car. Okay, but only thing is, those cars are driven by lead acid battery. That was the only difference. Okay, they have limitation. We'll see them. Then hybrid vehicle we are talking, correct? Hybrid vehicle, all the company, lot of research, correct? I'm also working on hybrid vehicle. I teach on hybrid vehicle technology course to students. And this itself was not new. It was a bit Porsche, Porsche company, which produces sports car. Porsche cars, not less than 1 crore, 2 crore, correct? They don't produce commercial cars. They produce sports car. Minimum price may 3 to 10 crores. Porsche cars, very expensive. Correct? They make only sports car. That company made some 70 years, we will sell an electric hybrid vehicle car, correct? Then came the petrol cars, correct? Petrol car appeared 1809, 1812. The most popular one of the petrol car in USA. Of course, many European company made, European company made petrol car 1910, 1920, 1930s. In US, the Ford company, the Model T, very popular. You can see the Ford T model car was very, very, very popular. Correct. So this was the first car, popular car using petrol engine. That means 1910. Before that, it was pure electric car. After that, more car companies came. GM, Chevrolet, Honda, BMW, Ferrari, Rolls-Royce, hundreds of company from 1910 till today, they are producing petrol, diesel cars, apart from hybrid cars, and now they started producing electric cars also. Please note that electric car started, then petrol car over to. That means I call as penetration of petrol diesel engines inside the car. Correct? Inside this car, you have electric motor. It was replaced by petrol because the production of diesel and petrol become easier, availability of petrol and diesel easier, and the energy density of the petrol and diesel is higher, and so that it can easily transported as a liquid from the refining place to the petrol bunk or petrol station, and easily transported, easily dispensed to the vehicle. It was available near the end user who has the car, bus, truck, correct? So it was easy. So because of that, it becomes the battery, the lead acid battery was very poor in case of energy density, correct? Weight to energy density very poor. That's why it failed. It was replaced by petrol engine. Right. So the electric cars not only was roaming on the earth side, in 1971 or 72, Apollo 14 or 15, correct? America sent astronauts, all of us know, correct? 1969, Armstrong, July, correct? I think July 5th or 7th, he landed on the moon surface along with Edwin Cooley. 2 persons. They walked for a few minutes, collected this one. They came. Everybody know. First man to land on Earth is land on the moon is Armstrong, Neil Armstrong. After one more person, the first mission, that is Apollo 11. 12, again 2 people went. They walked on the moon. 13 failed, so because it could not land on this one. 14, 15, 16, 17, correct, was the last. So if I am correct, around 12 people or 13 people walked on the moon surface. 12 people walked on the moon surface. All are Americans. Okay, within 3 years, 1968, 72. In the one of the mission, they took a vehicle, because if you walk, because the soft soil, gravity, you cannot walk beyond few kilometers. Nobody astronaut. So they wanted to explore large area of the moon surface. So this is actual photo, correct, taken by the astronauts when the vehicle is still on the moon surface. It would move for 22 kilometers. They said 2 passengers, 2 astronauts sat here in the seats. They drove this vehicle for 22 kilometers, 24 kilometers, collected a lot of samples, stopped, collected samples, and just left the car because they cannot bring it too heavy. They came back to Earth. Still it is on there. This is an electric car. Why I'm saying is, started the electric car, petrol diesel engine. Again, we are talking about electric car. Correct. So electric car was started 1970 GM, and it was using lead acid battery. It has a problem. They stopped it. Okay. Due to that, we are using petrol engines. And again, I told you, production of CO2 should be reduced. Correct. Producing the carbon dioxide should be reduced. But that means you should not use the petrol, diesel, fuel at all. That means no transportation. Billions of car, truck, bus, everything, ship, everything will be come to halt if I decided to not to use petrol. But then how to do transportation, right? Passenger, goods, all those things. Yeah, world will come to a standstill. So only way is increasing the fuel efficiency of the engine. That is first step. Correct. This was started 1970 fuel injection system. Correct. We call that port fuel injection system. Correct. Diesel engine is a common diesel injection system. If you see modern cars, any diesel car, they don't make too much noise. You would have seen. Correct. Modern car. You talk about, you go to any car showroom, they will have petrol car, diesel car. For example, Toyota, you have Maruti or Mahindra or any car factory, go to showroom. You take particular model, they have two engines. They say whether you want petrol engine based car, same model, this one. Sorry. If you use the diesel car, they're using what is a common rail diesel injection, which produces efficient engine, correct? Combustion and less the tailpipe product, these gases like smoke, we call a particulate matters, and nitric oxide produced by the combustion. That will be reduced using common rail injection. In case of petrol engine, they use what called port fuel injection, PFI or MPFI. This the system injects the fuel inside the engine, and because they vaporize easily and they burn, and 99% or at least 98% of fuel will burn, and so the more energies or torque is produced, and the fuel wastage is reduced. If fuel wastage is reduced, for the same amount of fuel, your car can go longer distance. If I, as a colloquial, if you want to say, if I take a car, if it uses a carburetor, old generation car, some 30 years before, 20 years before, still take ambassador car, Maruti 800 or Fiat car, which is 30 years old, they were using carburetor. Carburetor engine, the fuel efficiency is very bad compared to diesel. So for example, 1 liter petrol, you can go to 10 km, 12 km. Now modern car, same weight, same engine capacity, the fuel injection with port fuel MPFI can give another 5 to 6 km, 8 km extra mileage. That means with less fuel you are burning, your car goes for longer distance, you save money, because 1 liter petrol, for example, I can have a car, I pay 1 liter petrol 100 rupees in Chennai for approximately. My car goes Chennai city 10 kilometers. If I go to highway, it gives 18 kilometers. Correct. Another car gives 22 kilometers. So if your car gives higher mileage, that means you are burning less fuel. That means you are less pollution. You are producing less CO2. Correct. They call it carbon credit. You to go to internet to see carbon credit. That means if you are producing less carbon dioxide, you will be credited with some benefits. Worldwide it is there, but of course the government will get, we will not get directly. Carbon credit will be between the governments. They get money because of the whichever country produces less CO2 by using less fuel will be carbon credited by the countries which are burning more fuel, like US, China, all those things should give some money to countries which use less number of cars. This one, but that is not our topic. There you can find out carbon. So that means if I use instead of carburetor, if I use PFI, MPFI in petrol engine or common rail diesel injection diesel engines, modern cars, we can reduce the fuel consumption. So we are trying to go towards sustainable energy. Correct? We have less fuel is used, and you go longer distance, you save money, also produce less CO2. So greenhouse gas production, global warming is reduced. That's why all the government throughout the world are forcing the car company, motorcycle and truck company to use any one of this technology. Correct? Port fuel injection system or common rail diesel instead of old technology. Correct? They do. The another thing is, as I told you, this is called sparking petrol engine, in which the air and fuel is mixed inside the combustion chamber, spark is given, and the fuel burns and produces force which convert torque, and the vehicle moves. Then diesel engine, we call compression ignition. Diesel is injected, air is sucked in, and diesel injected, it burns and it produces a force that is converted to torque and drives the vehicle. The exhaust gas goes out. This is conventional, this one, in which we use CRDA technology or MPFA technology. The third technology is called as HCA engine, homogeneous compression ignition. which combines the advantages of the petrol engine and diesel engine and produces the power with less amount of NOx, NOx production, correct? And this advantage, but still it is in experimental state. So what I want to say is using different newer technology, fuel injection technology, like MPFI, CRDI or HCI technology, all car companies around the world are trying to reduce fuel consumption so that the CO2 production is reduced. So global warming, sustainable society or environment is created. But we have to eliminate all these engines instead of go to electric vehicle. Right? So ICE engines, sorry, we want to eliminate, but still ICE has a lot of advantage as on today, correct? It is a proven technology for last 120 years. Petrol engine, diesel engine, cars, all those produce compared to electric vehicle, modern electric vehicles, correct? Engine with varying size, power, speeds are available, starting with motorcycle and 50cc motorcycle to ship engine, correct? 1 lakh HP engine, correct? 1 lakh HP. I'm talking about not 100 HP, 1000 HP, 1 lakh HP, correct? Driving ocean liners or crude oil tankers or aircraft carriers, correct? So varying size are available, which is not available in the electric motor. That big is not available nowadays. That big batteries are not available. You cannot run a ocean ship or a crude oil liner 1 lakh HP using electric motor. Batteries are not available, correct? Only possible with IC engine and specifically diesel engine. Even petrol engine, they don't use it. Correct? IC engine technology, input energy is hydrocarbon fuels, as I told, gasoline, all these things. And the extraction of this one, petrol, diesel from the crude and storage and the transportation, handling, safety is much proven easy, highly matured because of last 150 years something. Correct? So because and the IC engine have reached close to the theoretical thermal efficiency, and because of all these advantages, we cannot get rid of this much because we need transportation, all these things. So that means we need to keep the IC engine slowly convert into electrical vehicle. Correct? Slowly. That is what you call the limitation. As I told you that they produce greenhouse gases. That is too dangerous. Correct? The efficiency is only 40%. For example, you burn one gram of fuel. Correct? I produce say 100 joules, for example. Correct? Then only 40 joules can be thermal energy converted to mechanical. Remaining 60 joules cannot be converted according to thermodynamic law. As a mechanical engineer, know that you are the thermodynamic course. All the engineers would have studied in first year, second year. So 60% energy become waste. That is major drawback of IC engine. Apart from producing pollutions, correct? And so what is the way to move forward? Go for electric vehicles. Remove IC engine from all transportation systems, bus, truck, aircraft, ship, everywhere remove, replace with electric vehicle. Why electric vehicle or electric motor instead of IC engine? Electric motors are very efficient, exceptionally high power to weight ratio. Size will be small, they can produce more torque. And the efficiency, you give electrical energy. For example, you give 100 watts electrical energy to electric motor, it produces 90 watts mechanical energy in shaft. But IC engine produces only 35 watts. Correct? I told you, only 40% is converted, heat energy converted into this one. That theoretically, practically only 35%. In case of electrical motor, if I give 100 watts of electrical energy, 90 to 95 watts will be converted to the mechanical torque. So that means very efficient. Correct? Next thing is adequate torque or wide range. So electric motor can produce the maximum torque. For example, you take an engine, we say 1 kilowatt, 100 Newton meter torque. Correct? Then the 100 Newton torque or peak torque, it happens when the engine reaches a particular speed, which is called peak torque speed, maybe 3000 RPM, 2000 RPM, 6000 RPM. When engine RPM is 0, the torque produced engine is 0. But in case of electric motor, if you give electric power, immediately the motor shaft is not rotating, but it will produce full torque, close to 90%. For example, I said that my electric motor produces 100 watts and produces, say, 10 Newton meter torque, correct? Peak torque, maximum torque. That means at zero speed, when I give the 12 volts and it takes, for example, it takes 10 amps current, correct? So automatically the power is consumed. It produces a full torque at zero speed, correct? That is major advantage. but IC engine cannot produce. I will show in the subsequent slide, you understand. So provide adequate torque over this possible. So electric motor produce full torque from 0 speed to maximum speed, almost. They are efficient, 95%. Control is easier compared to controlling IC engine. We saw the IC engine control. You need electronic control, sensors, lot of things. Correct, petrol diesel engine. Because of the cost of these diesel engine, petrol, CRD or MPF engine are very expensive. Compared to that, electric motor can be easily controlled using electronic control circuit. So it offers better solution. Okay, but electric vehicle also has a limitation. What are limitation? Energy sources. The energy source produces electric motors are moving. It is not stationary. You cannot connect it to the from using wire to your electrical source. Correct, plug points from your electricity available on your wall. Correct. So you cannot connect your wire because the vehicles are moving from one place to another. You cannot have long wires. That means only way for storing energies as a battery. But battery technology has a limitation. Correct. Till now, for last 100, 150 years, we are using lead acid battery in automobiles. For last 20 years, we have started working on lithium-ion battery. Correct, for last 20, 25 years. Still, it is lot of issues are that this has to be solved. And we are trying to go a new type of batteries also. So the battery is the main limitation of this one, because how much energy is stored in battery, how long the vehicle will drive is a reason. Battery weight to energy density is very low, very less compared to petrol. Hence, the range of the electric vehicle is limited. Now, slowly, we are improving. Recharging battery takes 60 minutes of one time. For example, you take lead acid battery. If we charge a battery, 12-volt battery, which has a 30 amps current, I use in my two-wheelers, correct? Small two-wheeler, electric vehicle, using it may go 30, 40 kilometers, 50 stops. After that, to charge the battery fully, it may take 5 to 6 hours. So that means you cannot travel. You cannot use your vehicle for 5 to 6 hours. That is one of the major drawbacks. Lithium this lead acid battery. Now people are coming with lithium ion battery or new type of battery which can be charged within 30 minutes, 1 hour, almost 50%, 70%, so that you can start driving. Still, you need to wait for 30 minutes, 40 minutes. But how about filling a petrol in petrol tank? My car, I go to my petrol bunk, my tank has 35 liters, I fill within 5 minutes. Possibly means within 4 to 3 minutes also. Maximum 5 minutes, I fill my tank. I just start driving. But even lithium-ion battery takes half an hour to 1 hour. Even to charge 50%, you have to wait for 50 minutes. That is another drawback, correct? And due to less energy, this vehicle cannot go for longer distance. One time you charge, my electric new cars, they say 300 kilometers, 350 kilometers. Again, you have to stop the vehicle, charge for 2 hours, 3 hours, or something, then only you can travel. That is so charging charge availability also limited, correct? So these are the problems. As I told you that IC engine also has a limitation, correct? So we want to get rid of IC engine. Suddenly you cannot leave it. You cannot go with the electric vehicle. Electric vehicle has a limitation. What is the solution? As I told you previously, just to quickly go through, these two graphs are very important. You can see the IC engine. One is called torque curve, other is called power curve, correct? Torque and power. This is engine speed. Engine speed 0. At the 0 speed, torque will be almost 0. Correct? Engine torque, this one, that means it cannot move. That's why the all IC engine based, petrol engine, diesel engine based car will have gearbox. Correct? When you press this one, engine speed increases. At 2000 RPM, it produces only 160 Newton meter torque. That is not sufficient to drive the vehicle stationary and is moving. So you go to first gear, the gearbox multiplies the engine torque 3 times, 2 times. So in first gear, so vehicle can move. Once vehicle start moving, you start going to second gear, third gear, fourth gear, so that at the top gear, engine speed will be same as the wheel speed, correct? Or propeller shaft speed. So that because of that, you are adding another additional mechanical arrangement. What is that? Petrol diesel engine without gearbox, you cannot drive your car. Otherwise, you need a car at 0 speed. No vehicle can produce torque. At 2000 RPM itself, it should produce the torque 260 Newton meter. This car needs, for example, 200 Newton meter torque. That means at 100 RPM to 1000 RPM itself, the engine should be, that means engine size will too big. But once you reach the full speed, you don't need that much torque. That means unnecessarily your engine weight will be more. So because of that, we have the gearbox. Gearbox adds weight. But if you go to electric vehicle, correct? So this is electric vehicle. You can see that at 0 speed, it has full torque. This is an electric motor. It produces up to 400 or 420 Newton meter torque. At zero speed, you can see the full torque. Here it is 0. Correct. So that means it has a flat torque curve up to 4,000 RPM, slowly drops. So this is a major advantage on the electric motor. Sorry. So if I combine both, correct? So then I get what you call a hybrid vehicle. What is solution? Having going for optimal solution, hybrid vehicle. Hybrid vehicle uses both electric motor and IC engine. Correct? Together, you get both the benefits. Correct? Wider operating range, wherever petrol station available, you can fill. Correct? So the hybrid vehicle can drive with engine as long as petrol is available. If petrol is not there, you can drive with motor, or combining both also you can do. So that means you get less pollution, you can longer operate. Correct. If battery is discharged, you go to nearest petrol bunk, you drive your vehicle with the IC engine, go to nearest petrol bunk, fill the tank and drive while the engine is driving, and it can charge the battery so that later you can use electric. So these are the advantages combining both. Okay. So there are different type of hybrid vehicles, correct? Combining IC engine with electric motors, correct? So that you get the advantage of both. So using hybrid vehicle is going towards cleaner and greener world. This was our topic, correct? We are talking about greener in this one. That means we are going to use less fuel, because hybrid vehicle, you can have a bigger motor, bigger battery. For emergency purpose alone, you can have a smaller engine. Correct. So that can be used for charging the battery or driving the vehicle, and slowly, and different combination is possible. That means you are going to use less fuel, and you are going to, most of the time, you are going to drive your vehicle using battery. Battery will not produce CO2. The only thing is the battery charging should be done using electrical power generated by wind energy, solar energy, or some other, not by thermal energy. If you do that, you can reduce this one. So there are different hybrid vehicle. See, hybrid vehicles start with pure IC engine, mild hybrid, medium hybrid, hybrid with pure plug-in hybrid, correct? Like that, there are different varieties are there. This graph shows that I can have pure electric vehicle, correct? This is pure electric vehicle. This is pure engine base. By combining these two different proportions, I can have the different type of hybrid vehicle, correct? Is possible. We don't have time to talk about all these things. I have already explained. By combining this one, I'll show you this one. Type of hybrid vehicle: series hybrid, parallel hybrid, series parallel, plug-in hybrid. And what is that? Correct? In hybrid vehicle, as I told you, you'll have two. You have an electric motor and also an IC engine. Correct? And now this is called as parallel hybrid. Correct? You can see that electric motor and engine are connected to a gear in a common shaft, which in turn is connected to the wheels. So when the engine runs, the wheel will rotate, or vehicle will move. When motor runs, the wheel will move, vehicle will go. That time engine may be off. Or I can drive both the motor, this one, and still I can drive. This is called parallel hybrid. Correct? So it uses engine power. This is called series hybrid. In series hybrid, you have the engine. Engine drives an electrical generator. That electrical power is used to convert to DC voltage, and that is given to a DC motor. Correct? Electric motor. But electric motor only drives the vehicle. Please note that in series hybrid, electrical motor always drives. Engine is used only for generating electrical power, which is used for driving the motor, also to charge the battery. So this is called series hybrid. This is called combining both. Correct? Engine, correct, and also the motor, and they are not directly connected. Please, engine motor is connected directly, but engine is connected to a planetary gearbox. Using this, the engine power can be given to wheel, or can be drive the generator and produce electricity and charge the battery, which in turn will run this one. Correct? So these are the very popular type of this one. The third is called plug-in hybrid. In plug-in hybrid, you have an electric motor and a small engine, and the engine is used for charging the battery. But you charge the main battery using in the home, correct? From wall mount plugging. And this is a main battery. Battery pack is this one. And also it has a small engine, which will be many times be gasoline engine, petrol engine. That engine will be used to charge the battery. If the battery is in the middle of the way, if battery is dead, then the engine will charge, engine will run and charge the battery so that you can drive. They call plug-in hybrid vehicle, correct? They have the advantage of both the vehicles. I have talked about what I have talked about, correct? So arrangement, it is not that you can get more knowledge about if you want. What is time? Can I, how many minutes I have or something? Okay, so that means if I use hybrid vehicle is better, I can reduce the carbon dioxide production. But best thing is go for pure electric vehicle, correct? That means no IC engine at all, correct? In that case, I need to use batteries, correct? So if I use pure electric vehicle, which uses electrical power from the battery, that also the battery is charged from the renewable energy, so solar energy or wind energy, geothermal energy, something like that. Then we can achieve sustainable battery, correct? This one. So we can go for greener and cleaner energy, correct? Pure electric vehicle, you can see that there's a battery. The battery power will be, generally battery is a DC power source. That will be 12 volt, 48 volt. That will be increased, power will be increased using driver circuit, power converters, and finally it goes to electric motor, which drives the wheel, correct? So this is electric car, and the electric cars are slowly catching up, correct? Hybrid vehicle, this is 2015. I got the chart from the internet. You can see by 2020 or 21, 22. This is 22. China was producing more number of electric vehicle. Hybrid vehicles also use. But now this is a combination of battery plus hybrid vehicle, plug-in hybrid. Pure electric vehicle, if you see that, again, China produced most of the electric vehicle, and from 2015 onwards, and other countries, Europe and US also produces, and use of number of vehicles. This is millions of vehicles, correct? Left side is millions of vehicles. This is here, correct? So the electric vehicles are catching up. So sustainable battery means you need to produce a battery which doesn't use the material, harmful material, correct? Sustainable, environmental. So the battery's major problem, environmental damages. It produces environmental damages because the lead acid battery has a drawback because it takes longer time to charge, and it has a less energy density and our weight to energy density. For example, the battery weighs around 20 kg. Only 2% of weight of the battery consumes the electrolyte, which is converted into electric energy. So only that means weight to energy density very bad in lead acid battery. That's why they invented lithium ion, they call LIB batteries. Okay, so these batteries, lithium ion batteries, has a higher voltage. They can work on higher voltage compared to lead acid battery, and but still they are using what you call as CRM, correct? CRM materials, what you call harmful material like cobalt. Lithium itself is a toxic material because lithium, these are used in this lithium ion battery. And if you use that, after battery life is over, because they'll be dumped, correct? They will pollute the environment. So use of non-polluting material to make the battery is called as sustainable battery. So that means lead acid battery and also lithium ion battery, which is currently available, both are not sustainable batteries. That means these are batteries which doesn't use harmful material to make the battery itself, correct? So global demand battery is increasing year by year. This graph shows that, correct? So basically lead acid battery, we know that it has an anode and cathode, and the anode is called positive electrode, which use a lead oxide, PbO. Negative electrode use a porous lead, Pb, and electrolyte solution diluted sulfuric acid, which uses sulfuric acid plus water, correct? So electrolyte, this one, and when it's connected to a load, current start flowing, correct? So the electrons start flowing, and that's how the battery produces. So now the battery, it has three parts: electrolyte, negative electrode, positive electrode made of this material. And the energy, electrical energy, is produced by chemical reaction, which is called as redox process, which is nothing but reduction and oxidation process. Okay. So now when you connect external load, they call discharging. That type, the positive electrode, are produced, correct? At what happens is the H2SO, sulfuric acid, will be split into hydrogen ions and sulfuric SO ion, sulfate ions, correct? And this one, and now the hydrogen ion reaches the PbO plate and the receives electron from it and becomes hydrogen atom, correct? Then the hydrogen atom further again joins with PbO2, correct? We know that what is PbO2? PbO2 is called positive electron, correct? So the sulfuric acid is split and the hydrogen ion moves to PbO, correct? Here, the hydrogen will combine with PbO and it produces water plus PbO, correct? Hydrogen joins with PbO2 and it becomes PbO and water. End product at the positive electrode is water plus hydrogen. PbO plus hydrogen. Now, the PbO2 reacts with this one, finally it will be PbSO and H2O. This is how the lead-acid battery happens. So then this SO2 goes to negative electrode and releases 2 electrons. This you can see 2 minus and 0 electrons. This is what coming out. This will be connected to this will be connected to load, correct? The current flow, the electrons start flowing like this, and so we say current is flowing. Electrons are flowing like this. This is how the lead-acid battery works. Okay, and we can see that lead-acid battery individual cell will produce 2 volts, and it takes time to discharge time. If I take 1 amps current, it may take 10 hours to discharge. If I take 1 amp current, okay. So again, if battery is discharged, we know that lead-acid battery is a rechargeable battery. Okay, in the fully charged condition, negative plate consists of lead and the positive plate consists lead oxide, PbO2, lead dioxide. And the electrolyte solution is H2SO for water plus sulfuric acid. That is called diluted sulfuric acid. That is fully charged condition. During chemical reaction, what happened already I told you, Pb and PbO2, Pb plus H2SO4 produces PbSO plus H2O, water plus the sulfate, correct? Lead sulfate. That is the discharge cycle and charge cycle. So this already you know about it. But as I told you, this has limitation because other people are going for lithium-ion battery. Lithium-ion battery use a different technology. It has an anode and cathode similar to any other battery, and it has an electrolyte, correct? And then it has another item called what you call a separator. So lithium-ion battery is a rechargeable battery, just like lead-acid battery. Store the energy using a special process called intercalation. This is called intercalation. And again, it contains anode, cathode, electrolyte. Anode can be made of lithium titanate or silicon, carbon, or tin or cobalt alloys or bismuth. Generally, they show lithium titanate, very popular. And cathode can be made of any of the material, correct? Lithium, nickel, manganese oxide. Generally, it will be oxide. LNNO, LiFe, PbO2, phosphate battery, cobalt battery, lithium battery. There are many varieties, correct? Lithium nickel battery, lithium phosphate, lithium manganese, cobalt, or nickel battery. These are different varieties based on what cathode material. Anode material, generally they use lithium titanate, but they can use this also. Electrolyte is mix of electrolyte salts in organic or inorganic solvents. So this picture shows how it is. Please note that in case of lithium ion battery, no electrons are removed. That is one of the main thing. In this battery, lead-acid battery, ion and battery, both are hydrogen ions, also electrons are produced. But in case of lithium-ion battery, inside the electrolyte, only ions are moving from anode to cathode, cathode to what ions? Lithium ions. That's why it's called lithium-ion battery. There's no electron flow inside the electrolyte. This is the important point you have to note. So lithium ion has a lot of advantages, correct? For example, by charging cycle, when I apply external power, you can see that this is called separator, this is called anode, this is called cathode. The ions, the plus one, correct? Plus sign shows that this is the lithium ion. Lithium ion, the cathode, start moving inside the electrolyte through the separator. There are small holes for this one, reaches the anode. During the time, the electrons are produced at the anode, those electrons will start moving in the electrical circuit. Electrical circuit, electrons are moving. Inside the lithium-ion battery, ions are moving. Lithium. This is the difference between lead-acid battery and the lithium-ion battery. Okay. So here, again, if I want to charge, if battery is discharged, again you have to charge. That means I connect external. This is charging cycle. This happens in the discharge cycle. From anode, the lithium-ion moves to cathode. That time, electrons are moving in the external circuit. So you can see that in both charging and discharging, the ions are moving inside the lithium-ion battery in the electrolyte from anode to cathode or cathode to anode, but the electrons are moving in external circuit. So this is the beauty of this one. And only one problem with this is it uses cobalt, nickel, and lithium. These items are harmful material. Lithium-ion batteries are better than lead-acid battery. They have higher energy density. Correct. Advantage lithium-ion battery, higher energy density, low self-discharge, correct, low maintenance, higher electrical load. Per cell it produces 3.6 volts. Lead-acid battery produces only 2 volts. So load characteristics, better load character, it can maintain constant voltage for longer duration, and variety of types are available. Like what I told is different types, correct? Lithium, nickel, phosphate, like this. These are the possible. What is disadvantage of this? Correct. Disadvantage is it requires a special battery management circuit to control the voltage, current, and the discharge rate. Apart from that, it needs a cooling system also. Lithium-ion battery needs cooling. Bigger lithium-ion batteries need cooling system, additional cooling system. These are the major drawbacks. So this also uses what you call as harmful material. So, but it has higher energy density, correct? And better than lead acid battery, but still has harmful effect, like using cobalt and nickel, all these things problem. So next thing is go for battery which is a sustainable battery. I just take another 5 minutes. Sorry for taking a little more time. I thought I wanted to complete. Sustainable batteries, there are new battery technologies people are developing. Efficient battery and use of recycling. Again, using the battery, discarded battery material is called as sustainable energy or sustainable battery technology. Producing electrodes for the lithium-ion battery. Generally, as I told that, they are using this kind of solvents. The solvents are harmful, not only cobalt, nickel, lithium-ion. These are the drawback of the lithium-ion battery. They are using solvents. You can say these are solvent use. These solvents are also dangerous, toxic. So this is a major problem. So if we can get rid of this material and cobalt, nickel in the lithium-ion battery, we can produce sustainable battery and which can charge, discharge more number of cycles when they don't produce harmful material when finally destroyed after the use. Okay. As I told you, these are this one. So now people are coming to new type of batteries, correct? New type of one is called zinc ion battery, and in which the anode is made of zinc material, cathode is made of manganese-based material. Please note that they are not using nickel or cobalt. Zinc ion battery is not using nickel or cobalt. Zinc may be little toxic, not as dangerous as cobalt or lithium or nickel. Correct? Large concern nickel also too dangerous. So cathode material also this one. So electrolyte also doesn't use the harmful material what you use in lithium. Here also the flow of current is due to flow of ions similar to lithium, same technology, same working principle, but anode cathode materials don't use toxic material. So zinc ion battery is the new technology which is a sustainable battery. Correct? Sustainable means not using sustainable material, which you call CRM material, critical material. Correct? They call critical raw material. Another word you can note down called critical raw material used in lithium-ion battery, cobalt, nickel, lithium. These three materials and the solvents used are called, these three mainly called as CRM material, critical raw materials. They are very limited availability, not available everywhere. Correct? Maximum cobalt, lithium is available in China, correct? And US and some countries and African countries, cobalt in only Congo. Congo produces one country around 70% of cobalt used in lithium ion. It is a dangerous condition. They are using child labor, all these things. That is the problem. So that means if I use lithium-ion battery, these are harmful effect. If I use zinc battery, I am not going to use these are CRM material, correct? Critical raw material, available limited. So zinc is available widely in many countries, correct? Similarly, you can use. So that is the advantage of that. But the principle is working is same. Ion exchange, all those things. The other advantages, zinc doesn't use material easily available. Environmental impact is very limited. It's not less toxic, not harmful. This one compared to lithium, cobalt, nickel, safer operation. Another one is zinc air battery. They are talking. Zinc air battery is another technology. It also doesn't use raw material like lithium, cobalt, all those things. So because of that, this is also a sustainable battery. Okay, zinc air battery, how it works, you can see that it takes air, oxygen from the air. One electrode is called gas electrode. Anode is a zinc material. Cathode is a gas electrode in which oxygen is used as electrode. That's why it's called zinc air battery. Correct? It doesn't use this one, but same principle. So this is better. Then sodium ion battery also now getting popular. Correct? This battery also uses sodium ion. Sodium, you know, is available easily. Worldwide it is available. And it is similar to same technology like lithium ion. It also same intercalating ion. No electron movement inside the electrolyte and inside the battery. Electrons are moved outside circuit only. Cell construction working all are same as lithium ion. Only thing is it is using sodium and other materials for anode and cathode. And because of that, so it is not using CRM material. Correct. So it is a sustainable battery. So advantage, anode is made of hard carbon, graphene or carbon. Cathode is made of oxides of iron and manganese. These items are easily available. They are not CRM material. Please note that critical raw material. They are not CRM material like this one, which is toxic. So that way disadvantage. Electrolyte use this also is mentioned. Basically, how it works, it talks about it. Main advantage is they were very cheap. Correct. Lithium is very expensive. Correct. But if I use sodium, correct, sodium per ton used in battery is only $2,000. Lithium is around 70,000. Apart from it, toxic, it uses. So if I use SIB battery, they are eco-friendly or sustainable technology. Correct. So these are, but there are limitations need to be covered. This is my last slide. Sorry for taking additional 15 minutes. Compared to sodium ion battery is the best. You can see the cost per kilowatt $40 to $70, but this density is correct. Cost is less, correct, compared to $137 lithium and lead acid around up to 300. Like this has a lot of advantage. Sodium ion battery, which is a sustainable battery, but yet to commercialize. There are a lot of limitations. So people are working on it to replace the lithium ion battery. Already lead acid battery has been replaced in electric vehicle by lithium ion. Lithium ion will be replaced by sodium ion, which is a sustainable battery. Correct. So these are the other, this one are there. Thank you very much for kind listening for last 1 hour 45 minutes. Thank you very much. I will stop my this one. Thank you.
Sir,
Yeah. Yes, please.
sir, is it concluded?
Yeah. Okay.
If you have anyone have the doubts, yes, you can ask. You can ask questions. Participants are requested to ask your queries.
If you have any query, I can answer 1 or 2 queries. Otherwise, we can close it.
So you can type your questions in chat box. Or you can raise your hands. We can unmute you.
Okay. If no more questions, I think we may close this session. Again, I wanted to thank Munuf and Sri Datta College for providing me this opportunity and share the knowledge. because many of you are definitely your teachers. FD program is meant for other teachers. I have taught more. I have taken special lectures in last 15 years, more than 70 FDP programs conducted by various colleges around southern part of India. So again, I wanted to thank the institute because this is going to enhance the knowledge of the participants. Thank you very much, Munuf, and the
Sir,
management.
one question from the participant, sir.
Yes, please.
So, what are the leading companies investing in sustainable battery technologies, sir?
See, sustainable battery technology itself is only new. Through internet, I saw that there are 3 or 4 companies which is working on commercially still yet to come. India, I did not see, but most of many companies are in China. Correct? The battery means many companies are in China. Only 3 or 4 companies are just talking. They are ready to come out with really working commercial batteries.
Okay, sir. So, and one more question from the participant.
Yeah.
And how does the circular economy apply to battery manufacturing and recycling?
Yeah, that's what I told you. The main problem with battery itself is the circular economy. All the raw material, there are many harmful material. Recovering the process, to recover the material from old batteries like lithium, all those things require a lot of technology, lot of energy. Correct? They're very harmful. But if you go to sustainable, correct? Because we talked about SI battery, lithium-ion battery uses sodium. Sodium can be easily handled. Correct? Recovery of the sodium from the discarded battery is easy and handling is easy. Correct? So because of that only, people wanted to go to SIB battery. It is not that even we know the lead acid batteries also people are trying to recover. But recovery is it is very serious, time consuming, dangerous, but then the energy consuming. Correct? But if you go to SIB battery, this is going to help because easy handling is easy. Correct? See, some material you cannot touch, even bare hand you cannot touch. Correct? Many material, but these batteries can be easily handled. Yeah, that way it can be easy. But as I told you, see, technology yet to go for large scale industrial production. Only few companies are producing sodium-ion battery. That also not fully commercialized, and they have limitation. It has a low energy density. That's why they're not able to sell. Compared to lithium-ion battery, the energy density is very less. If you see here, energy density will be very less. Correct? But because of that only, again, weight to ratio, all those things, when you see that comparatively, it is very less. Anything?
Thank you so much, sir.
Okay, thank you. Shall I leave?
Yes, someone is asking another question. Just I think no more questions.
Yeah.
So thank you so much, sir, for your insightful session on sustainable battery technologies.
Okay.
And your valuable expertise and in-depth knowledge provided us a deeper understanding. We sincerely appreciate your time and effort, sir.
Okay.
So thank you so much, sir.
Thank you. See you. Have a good night.
Thank you, sir.
This one wishes for the successful completion of this program to you as well as your college.
Thank you so much. Thank you.
Okay. Okay.
So next, I would like to invite our next resource person, Dr. Simhachalam Juttu garu. So he has completed his BTech in mechanical engineering, and he has also completed the PhD from IIT Delhi. So presently, he is working on fuel efficiency programs. So he is working with ARAI as general manager, and totally he has 23 plus years of experience in IC engines. And he has also published more than 25 papers in national and international journals. So I request Dr. Simhachalam Juttu garu, please take over this session. So I hand over this session to Dr. Simhachalam Juttu garu. Sir, please.
Hello, am I audible? Hello, hello.
Sir, your voice is audible, sir.
Okay. Yeah, very good evening to all the respected professors, because most of the professors I can see over here, and also other faculty members. So I think today I'm mostly interested on giving the today's scenario on fuel efficiency and its importance, and why we should study this particular activity. I will give you very brief on that, and also a couple of new concepts which we study from the fuel efficiency improvement point of view also I will try to touch. And if you have any questions in between, please, you can interrupt me in between, or you can ask the questions at the end of the session. So before we entering into the subject, I would like to thank Sri Datta Institutes for giving me this opportunity, and also giving the nice introduction about my profile. So with this, I would like to start the presentation. I have a couple of presentations. Maybe I will take you through one by one. Are you able to
Please
see my
share your
slide?
PPT, sir,
Yeah,
presentation.
are you able to see my PPT?
No, sir, no, sir.
No. Okay, I'm sharing now. Now, hope you should be able to see now.
Yes, sir, yes, sir.
Okay. Actually, why this topic is important? You might be aware about the current technology trends towards the EV, H2Is, fuel cell electric vehicles. These are the trend. This is the these are the current trends in the automotive sector, and also maybe in the mechanical division. Today there is no difference between the what is mechanical, what is electronics, electrical. So we are all working like a mechatronics. When we are working like a mechatronics, what we are neglecting is that fuel efficiency. So you might be aware that in 2016 there was a Paris Agreement where 194 plus countries have been signed to reduce the CO2 emissions. So whatever we are discussing about EV, fuel cell, hydrogen, the initiative behind all these things mainly the CO2 emissions. But really, these vehicles are good in CO2 or bad. So I don't know how many of you are aware. The fact is that in today, all the vehicles, all the EV, either you take EV or diesel, gasoline, fuel cell, H2Is. So depending on the source of the energy what we are getting, that will decide that the vehicle or the technology what we have developed is CO2 neutral or not. Current situation in India, we are depending on the coal electricity. That is about 75%. So 75% coal and 25% of renewable energy when we are using, then the overall CO2 impact on climate change is more or less equal to the conventional fueled vehicles, right? So because of this, we have a set fuel neutral or net zero emissions target by 2070. We have to see the alternative options so that we can reduce the carbon footprint. One of the option in that is improving the fuel efficiency. That is immediate solution to us. When we improve the fuel efficiency at engine level or at vehicle level. Sorry, just 1 moment. Okay, engine level or vehicle level. So now coming to the next emission levels or next regulatory requirements like BS7. So BS7 is demanding the efficiency improvement at vehicle level, not at component level or not at engine level. So the demand is changing because of the technology limitations, because of the energy sources from where we are getting. In that case, the focus is shifting from the component level like engine, battery or whatever it may be to vehicle level. The energy what X I am giving as an input to the system, how much that energy is converting into the useful work. Any idea? Do you have any idea that either you take conventional fuel vehicles or EV, what is the total tank to wheel efficiency or well to wheel efficiency? Any idea? It is hardly 15 to 20%. Even if it is less than that for the commercial vehicles. And commercial vehicles are polluting 66% approximately. So the focus now shifting to the fuel efficiency improvement and go to the advanced technologies like EV, fuel cell EV, and H2ICE. So now today my focus is here on real drive fuel efficiency and energy audit. First, we should know how much energy is flowing and where it is going. What is the potential area so that we can improve this? Based on this only, we are working on this. The difference between the real drive fuel consumption and engine level VSFC, you can see here. This is the real drive fuel consumption and engine level VSFC. There is a huge difference. If you can see a simple logic, if you can apply to anywhere, I can achieve the best fuel efficiency at engine level or the best efficiency at battery level, battery conversion or motor conversion or DC to DC conversion. But when it goes to the wheel, that is the efficiency actually we are going to use it for the drive. That efficiency should be improved. So that's the main agenda what global innovators, you can say, or global technology leaders or policy makers focus. So now the shift is from the component level to real drive fuel consumption. So engine BSFC will never reflect what is there on the road. And on-road fuel efficiency measurement is not a direct representative of real-world fuel consumption at all. Any improvement on real drive, really it will reflect on direct fuel savings or CO2 reductions. You can other emissions also. Even not only in engine level, even it is applicable to the EV also. It is applicable to the fuel cell EV. You might be aware that when it comes to the hydrogen, there are different hydrogen types. What are the difference? Gray hydrogen, blue hydrogen, green hydrogen, right? So when you depend on the blue hydrogen or gray hydrogen, and there is a huge difference in terms of CO2 emissions what we are giving to the environment. So that difference also needs to be calculated as a part of fuel efficiency. And now today in India, the recent development I just want to give as a gist to you. We are also seriously working on this one, how to reduce the CO2 emissions. How to reduce the CO2 emissions, not only from conventional, it is for the all vehicle categories. We do not have any methodology today in India. We don't have any methodology for the real drive fuel efficiency calculations, which are going to give the realistic measurement. So that is the basic bottleneck or gap which is there in India. But is it possible to test it? Is there any solution to test? There is no methodology available for India, especially. And Europe has developed their own methodology. They took 12 years to develop. Japan has developed their own methodology. They took sufficient time to develop. But when it comes to in India, there is no methodology. But that methodology, what we are going to do it, is also should be agreed by the all OEMs. Because my work, what I am doing here or what I work, is that it should be acceptable. I cannot do the academic type of work. That should be acceptable to the many stakeholders. Then only my work will have some validity or consideration. In this case, if you take a commercial vehicle of greater than 3.5 ton up to 55 ton vehicles, can I develop or can I test that vehicle on the road? It is quite impossible. So that's why there is an approach is called simulation approach. And this simulation approach is giving the many benefits. Like for example, building proto vehicle of for physical testing can be avoided because it's very expensive. It's a cost effective, quickly provide the solution, and you can do the parameter sensitivity analysis. Parameters in the sense there are n number of parameters. I will mention few names over here. Tire, vehicle geometrical dimensions, frontal area, gearbox efficiencies, differential efficiencies, engine and its subcomponents efficiencies. All those parameters we can study and understand which component has having potential to improve the fuel efficiency. This is a kind of a new program or new kind of approach what industry is following when it comes to the net zero policies, net zero emissions. Yeah, there are many technologies, many options, many open areas available. But when it comes to the net zero policy, everybody is working across the world, everybody is working. This will help us to not only improving the fuel efficiency, it will also help to extend the range of the EV vehicles, extend the range of H2 ICE vehicle, extend the range of fuel cell electric vehicles. Okay. Now we'll see the worldwide scenario very briefly and quickly. You can see here whatever the fuel we are consuming today in India, this consumption is about 73.6% is by transportation sector. About 26.4% is by other industries. Okay, here also you can see the distribution. This distribution. Then you can see this particular area. This is very interesting part, about 41%. Out of 73.6, 41% is only by buses and HCV category, and it is coming around 60 to 66 per 60% of this one. So now focus, it is already taken care by the many policy holders and many other regulations are already taken care by this segment, but this segment is untouched today. It was touched but not fully touched. So now we are working in this area. You can see in India, when we see the present and future, we are currently depending on one speed, that is constant speed fuel consumption. So one speed optimization is always easy than mapping the fuel efficient system across the entire operating zone. So which is not being used by anyone in India, anyone in the world. We are only using, now we are trying to discard this one. The future is that developing a new approach based on the drive cycle. of category of vehicles greater than 3.5 ton. So there is a new approach what we are developing. It is in work is in progress. I may not be able to disclose many of the things, but yes, work is in progress and it's good activity supported by government as well as other industry partners. If we see across the world, everybody adopted this approach except India. So India also hopefully in couple of years to 4 years time span, it will be adopted most probably. We are trying for that. What are the key benefits? The benefit is that we can estimate the how much CO2 emissions producing by this exactly, and also support the global warming policies as well as Paris Agreement policies. And the procedure is that it will help to reduce CO2 emissions by setting up the targets based on the actual predictions of any vehicle category. So these are the conditions. We can also achieve the national level. It will also help to the manufacturers, and it will also help customer to select his interested vehicle or his interested model. So this is one small example what we have tried out, and this is validated within 3%, which is acceptable. The work is in progress. Okay. Before going to this type of activity, we need to analyze the how much energy is distributed. You can see, hopefully you will be able to see how much energy is losing at engine level, how much energy loss at vehicle level, drag, gearbox, differential, and other areas. Once we can understand these locations, it will be easy for us to identify. So here, this particular concept or this particular approach, we are not limiting to only commercial diesel engines or gasoline engines. This concept is applicable across the any vehicle category. Let it be EV, let it be fuel cell or hydrogen. So it's going to be applicable. Concept is remains same. Only we have to do the application research. So you can see that overview I'm just giving you over here. Any vehicle will have these different types of losses. 100% energy when we are giving the tank to wheel efficiency, it's going 100 is going to come down by 15 to 16%, or maybe sometimes up to 20 also. In electrical vehicles, it may go up to 23 to 25%. That means almost 75 to 85% energy loss is in these areas. If we can try to improve 1% in all these zones, that will be a great benefit to the society. At the same time, end user will get benefited. So this is the like kind of a program what we are doing, and it's a new approach and new program to help and to find out the different ways to improve the fuel efficiency by studying the different vehicles, different parts, different subsystems losses and its efficiency improvement. So in this process, we can do approach like this. Maybe if why I have given this presentation, there is a interest and logic behind that. Since being a faculty members you are all, so this kind of approach may be helpful to you to do some more research in this area. That is the main thought process to select this particular topic. It may be very short and small topic, but interesting topic. You can see the different vehicles, which vehicle is giving better efficiency, which vehicle is having more potential. We can do this benchmark, and this is important task in this. We have to study based on the real world usage pattern, that is RWP. So this real world usage pattern need to be generated and not required to generate for every vehicle, but depending on application need to be generated. Now we are developing this particular map for entire vehicles in India. The second is that aerodynamics testing and simulation. The testing of the aerodynamics, you can see here, you have to build the vehicle, and that build vehicle to be tested in the field and measure the aerodynamics drag. It's a very expensive process and need to be established a simulation approach. And again, aggregates or auxiliaries efficiencies. This data will be useful to identify the percentage distribution of the energy losses. This can be used for any vehicle, as I said, and bring it to the all this physical testing to the desktop level assessment. But here, one thing we should remember or need to be understood, the quality of the data, what we are going to acquire, that will only make you to make us differently in achieving the results here. Suppose if I get 12% gap correlation, not acceptable. That gap should be at least less than 5%. And that gap cannot be achieved by manipulation. So that gap has to be achieved on its own. But when it is possible only if we can give due attention during this particular activities, all these activities. So this is the kind of challenge here, definitely. So once we do this one, we can get this type of efficiency distribution. Now, in this particular program, this is a small example. I just want to show it here. If you can see here, this is 15 to 18%, and this is 12 to 14%. This is about 58 to 61%. If I improve anything over here, this entire improvement will goes to here. This is what we need on higher side. So this is how we generally do the fuel efficiency improvement programs on vehicle energy audit or for different vehicle categories. These are all these vehicles possible to carry out, and we are working on this very aggressively with entire system. We have generated a system. We have some consortium formed for this, along with OEMs, ministry, and so many other stakeholders. So with this, I will stop this presentation. I will go to the another presentation here. Any questions till this point? Please let me know if you have any questions so that I will try to answer. Otherwise, I will switch over the presentation to another new technology concepts where we will get the good fuel efficiency improvements.
Dear participant, do you have any questions?
Okay, you can park your questions.
You can type your questions in the chat box.
Yes. So I will start from this slide here. There is some change in the number years. Okay, small change in the years. So otherwise, objectives are more or less same. Okay. You can see here, particularly focusing on the CO2 emissions and GH. Yeah, years are going to change, but obviously we have to reduce this one. This is possible only through fuel efficiency. So one program I am going to show today that what way we can improve the fuel efficiency at engine level. Okay, that one program I want to show. See, we have a lot of demands. You can see here all these demands, and we have some of the requirements, and we have another limitations of this one. Demands are legislative cycles I have to meet. Extreme operating conditions, engine will run or vehicle will run. Technology options various. The cost of the total engine or this one will be high. and I need low maintenance, ease of service. These are all demands from the various sources. Because considering all these demands, I have to meet emissions compliance, efficiency improvement, and my system should be accommodatable for the different fuels. You know that flex fuel concept is in discussions today. You might be aware, flex fuel concept. Okay, and dual fuel concept is already there, but people are going for the flex fuel concept. But for all these things, there is a limitation in the sense time, manpower, resources, cost. So any program when we do, we have to see from all these angles. One is legislative requirements, second one is compliance, third one is what I have to develop. So we struggle between all these parameters before going to the any new activity. So this is the one activity we have taken up to improve that. There are three parameters. One is reduce the weight. When you reduce the weight, now you know Bharat NCAP is there, the star rating from the structural point of view. Bharat NCAP. The full form is that Bharat New Car Program. Second option is increase the power from the same engine and low emissions fuel consumption. So in this, there are different losses. Most of the professors might be aware about what are the different losses. So these losses, we try to tap it in this program. So this one, how many of you believe that diesel engines are going to be there for long time? Do you think that today, in present scenario, EVs are going to replace diesel engines? Any idea? Just a question to you all. Any idea or any guess on that? As far as I am concerned, okay, my experience or my analysis point of view, diesel engines are not going to die. It will be there, at least the today who are all there in this particular session, till our last breath, diesel engines, definitely it will be there. That is the first note. The second is that to replace diesel engines with battery is going to take very long time because of its own limitations for this particular category. Third point is that if we can replace, or if you are planning to replace diesel engines with fuel cell EV, again there is a technology limitation, technology readiness, technology maturity, and at the end, overall cost of the system. While we are selecting all these parameters, emissions at the source, whether the emissions at the source same, high, low, this also play a role. So considering many other parameters, let us focus on the diesel today. This I will skip it for the time being. We can also see here that there is a balance between the global emissions and local emissions. As far as present regulatory point of view, this is our main concern. But when we see the future generation sustainability point of view, this is the concern and worry. That's why Paris Agreement 2016 happened and 194 countries signed on that. So this now the focus is shifting because this is already taken care by many technologies. And this is the one which is not completely attended or attempted by the governments or the research bodies or advanced countries like USA also. today I think you have seen news, they want to come out of the Paris also. Okay, that we will not discuss. So we tried one of the concept, low temperature combustion concept here. And we have taken one engine and modified that engine and see the possibilities to improve the fuel efficiency by reducing the emissions. And when if you can see that low temperature combustion concept, this is applicable to any type of engine. Nothing related to the only diesel. This concept is applicable to any engine. This concept is applicable to alternative fuels like CNG. H2 is also, obviously it is useful. So there is kind of a balance between the SI engine, CI engine, low temperature combustion or homogeneous combustion. So this balance will help us to reduce the emissions at source and also fuel efficiency improvement. I'm not going into the details because of the time constraint. Okay, the concept when we see here, any engine if you can run, you cannot avoid the formation of the soot and also NOx. If you try to reduce soot, then NOx will increase. If you try to reduce the NOx, soot zone will increase. And always engine will travel like this particular orange color line. It will travel, its path is through soot formation as well as NOx formation. So in new technology, what we tried couple of 3 years before, we try to run the engine in this path, avoid the formation of both soot and NOx, and then improve the fuel efficiency. So there is good amount of work we have done, and that work also I will show it here. Okay, the concept here is the flame propagation and also start of combustion, duration of the injection, everything is to be tuned. As I said, diesel engines are not going to die, and we are working extensively on diesel engines, and we are implementing this concept. Okay, means as a mechanical engineer or as a technical person, I cannot leave what I am doing, but at the same time, I should add what is required for the future. This is how we are working here, and this helped us in many programs and many projects. So we got very low NOx, we got better fuel efficiency, we got cost-effective solution also. This is the practically implemented program I'm talking here. So this difference, I will not go through this one. I will go to the results quickly. Yes. Yes. Here I will go through this one. This is generally our conventional operating zone of the diesel engine, and we generally operate. This is the operating zone, or when we run the engine or vehicle on road. This is these are the points where engine will run. So this entire points matrix converted into the few points, approximately 14 points by using weighted average method, 14 points, and these 14 points we optimized first. After optimization, we identified the zone where we can run the engine with full low temperature combustion concept. Then thereafter, we have minimized the LTC concept and slowly moved towards the conventional DI. That means partially benefit we have taken by using the new technology. While we are moving from zero load to the full load, we have this transmission is happening slowly, gradually. So this is how we have mapped the entire engine program first. Then you can see the results here. How beauty you can see. Conventional is 6.71 NOx. A new concept is almost 1/3. And particulates also almost 50%. Okay, this is how the new concepts are going to help us. But of course, facilities are also important. Manpower is also important. Like you can see here, fuel efficiency, 8% improvement we got it only from engine. 8% improvement. So you can see here that entire operating zone of the vehicle. When vehicle is running in the field, that how the engine is operating, and each operating point, what is the BSFC? This is the cumulative BSFC measured at different points, and this cumulative BSFC converted into the cycle BSFC. So this is one example I just brought to your notice to say that there are many open areas, there are many new areas which are available to improve the fuel efficiency point of view. Now I'm switching to the another presentation where you can see the fuel efficiency improvement with different parameters, or you can say that parameter sensitivity on fuel efficiency. Give me 1 minute time. I will switch over to this one. Because of confidentiality, I will not be able to show completely, but I just want to give some kind of energy or some kind of inputs from research point of view. Just a couple of slides I want to show here. You can see here one small program what we are doing here. This is a battery. Okay. So when we see the battery, it's like a motor. When we see the motor will have a typical characteristic. What is the typical characteristic? So at low speed,
Excuse me, sir.
very low
Your
speed.
voice is not audible.
Is it? Now, am I audible now?
Yes, sir. Yes, sir.
Yes.
Your
Okay.
voice is audible.
Audible. Okay. It's like a typical characteristic motor will have. Initially, it will have good torque, but that speed is very low. But as the speed improves, then the torque suddenly drops in the motor. And also efficiency map, if you can see, it's different efficiency at different speeds. Then where to run the vehicle? What should be the zone so that we can get the maximum efficiency or maximum well to wheel or tank to wheel efficiency, battery to wheel, here in this case, battery to wheel. So now here we can study given motor characteristic curve. This is the characteristic curve where the points are mapping, whether it is in good efficiency zone, whether it is in the bad efficiency zone. So this will help us to give a feedback, or this will help us to understand what is exactly happening in the motor. If we can get this particular data accurately, I don't think it is possible from the academic point of view, getting a data, but if we can tie up with some good university, either in China or maybe outside, it is possible to study more in detail. And this particular concept will help us to understand the specific energy consumption. What is specific energy consumption means? How much kilowatt hour is consuming for every kilometer, so that this will help us to improve. This has to be improved. Now, this is the value of current vehicle on road. This is the value we have targeted. This is the value we improved. Okay. Just I'm giving a gist because I cannot go much details of this particular program because of confidentiality point of view. So there is lot of scope, fuel efficiency improvement point of view. When we say fuel efficiency improvement, I'm not limiting to only IC engines. I'm not limiting to only vehicles. I'm expanding this requirement across the platforms, starting from the IC to fuel cell vehicles. Okay, this is just an overall overview of my presentation. So I want to conclude over here. Hope I have given some bullet points of future requirement and bullet points of what is happening in the current scenario across the globe to control the CO2 emissions and what government is thinking and what industry is also
Excuse
looking
me,
for.
sir. Your screen is not shared. Your
No, no.
screen is not visible, sir.
Okay, what I am saying is that I'm concluding my presentation over here. Okay, so you, if before while concluding the presentation, I'm just giving a small gist about the presentation. My main objective of our idea of today's presentation is that what exactly world is looking for, that not only technology, they are also looking for the converting the existing technology to a efficient technology to reduce the CO2 emissions. So in this area, what we are working and how we are working and what are the areas we are touching for this as a part of net zero policy 2070. We are part of, we are working for the net zero 2070 part. And in this many programs, some of the programs I will not be able to disclose, but hint I have given so that some of you can pick up and we can work together also if there is a good activity, a good scope to work together. And if you have any questions in this area, please let me know. I will try to answer. This is very brief about my presentation.
Sir,
Yes, sir.
one question from the participant.
Please, sir.
So he is asking, can you explain the role and importance of aerodynamic simulation over there?
Okay. So aerodynamics are contributing by approximately 15 to 23%. The area means contribution 15 to 23%, depending on the design, depending on the type of load, like category of the vehicle. Okay, if the design is bad, it may go up to 30% also. That is the role of its aerodynamics in fuel efficiency. Then second point is that if we can reduce, if you ask me a question that what is the current CD into A, that is aero drag, is about 0.9 in India. 0.9. That 0.9 should be bring to the 0.6. If we can bring that from 0.9 to 0.6, there is a possibility to improve the tank to wheel efficiency by around 1 to 1.5%. Is it
I
clear?
hope the participant.
Hello? Is it clear?
I hope the participant got the answer. So still he has any queries, he can ask.
Yes.
Okay, thank you. It's clear. And one more question. How is the resale value of battery vehicles calculated, and what are the factors which influence it?
Very complex question actually. Okay, very good question and at the same time complex. See, battery electric vehicles resale, I don't think so we are right people, but okay, as a discussion point of view, life of the battery plays critical role here. Okay, that's why, are you aware there is a MG has launched a vehicle, a small vehicle. Any idea?
Yes, sir.
Okay. You know what policy they are thinking? Because of this resale issue, people are taking back step to buy the vehicles. You might be aware. So what they are thinking, or they might have launched, I'm not aware, but I heard that this point. They want to take the responsibility of the battery. Understood?
Yes, sir.
Pay the cost of the vehicle without battery. For example, without battery or critical technologies, vehicle cost is 5 lakhs you pay. Right? That vehicle cost is 10 lakhs. I am paying only 5 lakhs for that vehicle. While running the vehicle, I have to pay the per kilometer cost to the company. If I run 10 kilometers today, we'll have agreement. Okay, I finished so many kilometers in a month. That much money I have to pay. Anyhow, I have to pay it for fuel, right? Instead of paying to the fuel, I will pay to the battery people. So that concept is coming to avoid this or to come out of this problem. Okay, definitely this is issue. I think one more question. In the future, all vehicles or mechanical components reduced by how much percentage? It's improving fuel efficiency or not? See, I will take an example of engine. How many aggregates are there in engine other than combustion? One is steering pump, water pump, oil pump, compressor, fan, right? These are the alternator. These are the 5 aggregates, six aggregates, and all 6 aggregates having potential to improve. All 6 aggregates by reducing the heat losses. Number 1. Number 2 is that vehicle aero drag. Aero drag is another key area. You can improve the fuel efficiency. Sorry, this is number 7. Number 8 point is tire rolling coefficient, rolling resistance. There is an improvement possibility in the tires. 9th point is that fuel efficiency in the improvement in the gearbox, improvement in the differential, improvement in the weight reduction. All these points definitely will help to enhance the fuel efficiency by at least 1 to 5%. And 1 is itself is very good percentage. 5 is extremely good. Is it clear to the participant?
Yes, sir. I hope you got the answer.
Okay. Actually, this is really burning topic today. And if you go to the website, you can type fuel efficiency improvement programs. Particularly, you can type what Europe is following, what US is following, what South Korea is following, what Japan is following, what China is following, what India is doing. Okay. So this from the net zero point of view. I'm just putting from the net zero point of view. So you will get a lot of inputs also, a lot of information. You can get it. And this program is going to be started in India very soon. Very soon, maybe in a month time, it's going to be started.
So another question. So
Yes.
what is the influence of IoT implementation in the automobile vehicles?
From what aspect? Is it from the efficiency improvement or is it from the safety?
Yeah, efficiency improvement, sir. Maybe.
Okay. See, it will have definitely role from the IoT's point of view also. For example, maybe I will take one small example of this one. Okay.
Okay.
Can you give any example? I will connect to that. Can we take ADAS? ADAS is also part of IoT, right?
Yes, sir.
Okay. Okay. So I will take one small example of ADAS. Cruise control. Have you heard? We know that cruise control, vehicle cruising.
Yes, sir. We know.
Eco cruising and eco roll. You know eco roll. Eco roll is also comes under the implementation of IoTs. Okay. So I don't know how much you are aware about eco roll, but I will explain here. When the vehicle is going from the top hill to the downhill, right? What we do generally, either we apply the heavy brake, am I right, to stop the vehicle or to control the vehicle. So when we implement these particular things, IoTs, it will automatically take care of that vehicle brake without giving the aggressive braking or without stopping the engine or some other things, right? So then it will balance in such a way that when to brake or when to control, these IoTs will take care of that, so that to reduce the losses. IoTs will help to reduce the losses. IoTs will help to control the program so that smooth movement it is possible. This is one simple example. And second example, I just engine start stop. Are you aware engine start stop? What will happen? You are using an engine. You take a car engine, gasoline engine. You are in the signal point, right? At the signal point, 90 seconds signal. Engine will be stopped automatically after few seconds, and it will start. When it stops, it will stop in such a position that your frictional losses will reduce when you restart the engine again. That is another kind of example. Main 100% IoT linked is cruising. Cruising also will help in such a way that your speed control is possible and your drive lane is also possible to control. So many advantages are there. It will definitely help to improve the fuel efficiency. Mainly range. If you talk about conventional fuels, fuel efficiency. If you talk about EV range. If you talk about fuel cell efficiency, range also going to be there. When you talk about H2 ICE engine, again range will come into picture. It will have a great role, I can say in simple word, but with few examples. Yes, I think there are few more questions also. It looks to me. Okay, so somebody is asking about the presentation, and I will try to see the possibilities from the confidentiality point of view and share with you. Definitely. Yes, IoT safety is 100%. It is having great role in that. There is no doubt from the safety point of view. Apart from safety point of view, there is benefit from the efficiency improvement also. Yes. Any more questions? I'm a bit practical person. That's why I have given.
Dear participants, do you have any questions you can ask?
Yeah, before you
To
ask.
raise your hands, we can unmute you. Just you can talk directly.
Yes, yes. I'm a practical person. That's why I have taken today's session in such a way that what we do, what is the demand from the environmental point of view, and also from policies point of view, and added the what world is doing in that direction. So the main basic idea to give the gist of points where you people can work in that direction. Some of the areas can be picked out.
Sir, thank you so much for your valuable presentation. So,
Thank you, sir. Thank
is
you.
there anyone, if you have any queries, you can ask.
Yeah, if there are no questions, you can reach me even later on also, not a problem.
Okay,
I'll
sir.
be happy to entertain or discuss on these areas because these areas are very new areas and need lot of collaboration, lot of ideas from different parts of the technology sections. So you can reach me also, not a problem. You can take my number from Sridatta, is this one, from this sir.
Yes, sir.
Yeah, you can take.
So,
And if I am not lifting the call immediately, maybe whenever I am free or whenever I finished my meeting, I will definitely call back.
okay, sir, we will provide the details of you for
No,
the
no,
participants, to
no
the
problem.
participants.
Yes, yes.
So if anyone have any doubts in future, they can contact you, sir.
Yes, yes, yes.
Okay, thank you so much, sir, for
Yes.
your nice
Yes, sir.
presentation.
So thank you, sir.
So thank
Actually, sir, recently we have launched one program in this, in hands of Honorable Minister Nitin Gadkari, sir. A program we have started actually.
you. Oh, good one.
Okay, sir. Thank you very much for
Okay, sir. Thank you so much, sir.
for this opportunity. Okay. I'm very short presentation.
It's good presentation, sir. It's very helpful for the participants.
Yes, sir. Yes, sir.
Thank you so much, sir.
Thank you very much, sir. Thank you, sir. Can I leave, sir?
Yeah.
Okay.
Yes, sir. Yes, sir. Thank you so much.
Thank you very much.
Participants are requested to fill the form for the attendance purpose. So don't forget to fill the form. The form is posted in a chat box. So if anyone didn't get the message, so you can ask me directly through WhatsApp number. Okay. Thank you so much for the participation. In tomorrow's session, we can meet with other two experts. Thank you. So good night.